This is the engineering analysis for the automatic card dealing machine team. Our analysis was motivated by our pre-prototype. We would like to analyze the speed at which both motors are running and the accuracy and preciseness of the dealing of the cards. We will integrate a microcontroller as well as an optical sensor to provide adequate control and flexibility of the machine.
We analyzed the surfaces we would deal on and the performance of the motors. In addition, we programmed our microcontroller to vary the number of players. We analyzed the accuracy and repeatability of the machine.
We tested the friction of a wood surface and carpet by measuring the distance each card traveled. We compared the resulting averages and standard deviations. We also tested various voltages, 9 volts and 12 volts, on our motors and calculated the revolutions per second for each. We also calculated the weight of an individual card and used the number of undealt cards to determine the pressure required to deal a card. We also computed the ratio of wheel rotations per machine rotations, which will later be used for our program.
The code that runs on the microcontroller is integral to the operation of our machine. The code performs some initial calculations, then starts a loop that deals one card and rotates until all cards are dealt.
For operation testing, we performed 3 trials to get an average of the time it took to deal, time to deal one card, and total time at 9 volts and 12 volts.
Displayed are the results of the friction testing. As you can see, the wood laminate has further travel and a larger range than the carpet and thus lower friction. The slide will be modified so that the cars will be able to completely exit the slide.
From our test results, it is clear that the motors operate faster at 12 volts. In addition, the top motor is faster than the bottom one. This will be useful in shortening the machine's runtime.
Since the machine could not deal all 52 cards, we wanted to calculate the least amount of pressure required on the top of the deck to deal all the cards. This will allow us to size a card weight for our final prototype.
After measuring the diameter of the wheel and diameter of our machine's rotation, we were able to calculate the circumference of each and determine the number of wheel rotations per machine rotations. This data is used within our program.
Here is the code that will be loaded onto the microcontroller. We were initially able to achieve control of the motors, but the unexpected failure of an IC chip means that most of this code is untested at this point.
With the 12 volts, the machine was able to deal more cards and take significantly less time to deal one card.
The major change going from our pre-prototype to our final prototype will be the addition of the microcontroller and its associated program that was developed during analysis. We now know that the motor speeds and delay time will need to be carefully calibrated to provide accurate and precise card dealing. A surface material such as felt will provide an intermediate level of friction between the carpet and slick table surface, and the card slide will need to be modified so that cards will not occasionally get caught at the end. In addition, inconsistencies in the card dealing will be reduced with a new dealing shaft that is precisely machined and not eccentric as it currently is.